Hey guys, so welcome back. In this video, I will mainly talk about hybrid beamforming. For that, let me revisit the concepts that has been taught in the previous videos. Uh, the thing is that in order to form the beam, RF beam in a particular direction as shown here, I was mentioning that we need to give the progressive phase shift across these antennas. So we were performing the phase shift in the analog domain by giving the respective values to the analog phase shifters, right? So if you perform this kind of beamforming is known as analog beamforming, right? Now the thing is that can we shift this phase shifters to the digital domain? So for that, let me take this block diagram which I was explaining in the previous video. Let's say if the signal analog signal is S1 of t just before giving to antenna. Okay, let me say here. Okay, here let us say this is S of t. This is also S of t. Then um, we have got RF chain here, right? We have got RF chain here, and then before that, the signal will be in the discrete domain. Okay, so let's say this is the one. Now I will expand this each chain below here. Okay, let's say x1 of n. So in case of OF or DM, or in case of 4G or 5G, we gonna first give to RE mapping. Okay, once it is mapped, then we gonna perform OFDM signal, and then we get x1 of k, then analog to digital converter. This is where from discrete to analog conversion is going to happen, and this is S1 of t, right? So I was mentioning that at this point in time, we are using hardware phase shifters. So can we give this phase shifter in the digital domain? So here x1 of n e to the power of j phi. Okay, can we give like this? See, note that this phi is independent of n. So whatever operations you gonna do, RE mapping or OFDM signal generation, this e to the power of j phi can be taken common. So here also, if you see e to the power of j phi remains as it is, and this will become x1 of t. The corresponding phase shift will be taken care here in the time domain, and the same phase shift is gonna will be taken care in S1 of t. Okay, so basically S1 x1 of t, let's say this is some cos um, 2 pi f1 t some signal, then it will be cos of 2 pi f1 t plus phi. This is how the phase shift will be taken care even at this point, the same. So the phase shift which we are going to give in the analog domain can be equivalently implemented in the digital domain. If we perform such an operation, then what do we say? That is digital beamforming. So basically, what I would say is, uh, what I would say is, okay. What I would say is, so let me write it here. So x1 of n, okay, x1 of n e to the power of j phi. I'm going to implement here, and then whole chain. I'm not going to write it. So then finally, if I have s1 of t, then I have s1 of t with with the signal shifted by a phase shift value of 5. Okay, these are all RF chain. So then here we don't want any here we don't want any analog phase shifters, so we can directly give to antenna. So this, if we are performing this phase shift values in the digital domain rather than in the analog domain, then we can say that this is a digital beamforming. Okay. Now the thing is, what about hybrid beamforming? If we perform some phase shift operation in the digital domain and some more phase shift operation in the analog domain, if we have both of these things implemented, then that is called as hybrid beamforming. I hope you got this clarity. Okay, maybe this would be given as some 45-degree, and in the analog domain also, let us say I will give as 45-degree, then 45, 45, I would say total 90-degree. All right. So the effective of phase shift here is 90-degree, which means that as per our previous calculation, 90-degree phase shift across one antenna. Here, let's say I'm giving 0 degree. Here also 0 degree. Then the beam would be formed the 30-degree direction, something like this. I hope you got this clarity with respect to hybrid beamforming. In the next video, I will mainly talk about how this precoding based beamforming is going to influence the RF beam on a similar lines. Okay, we will see that in the upcoming video. So before I wind up, I want to talk about little more. I want to give little more information about the concepts which I had spoken in the previous videos. So the first one is with respect to this beams. Okay, so I was mentioning that, okay, let me come to this point itself. Okay, so at this point, how can I write? I was trying to write it in the vector form. I was writing s1 of t, then 1 e to the power of j5. I was writing it like this. So if I go back to that, if you see, this is how I was writing it. Okay, so but what I want to mention is it the right way to represent like this? The answer is no, because see, S1 of t, now it is in analog domain. Okay, first thing, and it is a real signal now. So to this real signal, at this point in time, when we are going to apply the phase shifter using analog phase shifter, this quantity has to be real. So I was mentioning for the sake of understanding, but this we will just take it as 1 and 5. So what we can say is this 5 is analog phase shifter. Okay. Um, I hope this is also clear to you guys. So this is one correction which I wanted to mention. So in the next concept, I was mentioning that how can we give the phase shift values across various antennas if we have for more antennas or something like this. Okay, I was basically mentioning that if you want to form the beam in the 30-degree direction, something like this. Okay, then if this is a 30-degree, then I had calculated that my phi value should be 90-degree. So that is across the second antenna. This we had derived, but what should be the phase value for the third antenna, fourth antenna, and like that eighth antenna? So I was mentioning that we need to give the phase values like this, but let us try to derive it, or let us try to see the answer by taking the four antennas as of now. Then you can expand it to multiple antennas very easily. Okay, so this is how the four antenna, let's say, looks like. So I want to now form the beam in the 30-degree direction. So let's say I am going to form like this. Now I was drawing the perpendicular direction, right? So let's say this is a perpendicular direction. So like this I can extend this till this point, right? So similarly from here I can draw, from here I can draw. So if you clearly see this is the distance which I was taking it as x. This is the distance x meters which the signal should travel extra, right? So this is my theta a. Okay, so finally, so this is x, then if you see this is x, this is x. Okay, then this is x, x. So this signal from this antenna should travel the distance x distance extra compared to this one. Okay, this is, let's say, it's just the starting. So this one would be, if you see, 2x extra it has to travel. Okay, see this point. Okay, this is not even started. This has to travel x distance. If you see this point, so x plus x 2x. Similarly this point, this has to travel 3x distance. So for these two we had already derived. If it wants to travel a distance x, then a phi value which I have to give is 90-degree. So if I give this is 0 degree, then this is 90-degree I have to give. Then 2x means definitely I have to give 2 into 90-degree, and this is 3 into 90-degree. That's what I was explaining in the previous video. Okay, I hope with figure it is much more clear to you guys. So that's what I had given here. Even for 8 antennas, the concept remains same, and it will be 7 into 90-degree. So with this, I want to wind up this video now. Thank you very much. Have a great day. Bye bye. Please tuned, and I will come up with more videos in the future. Bye bye.